Hello everyone. In this class, I am introducing new chapter, reflection of light at plane surfaces. Before discussing the reflection of light at plane surfaces, we will discuss about light. Okay, and we will discuss about light, source of light, speed of light, and optical medium. We will discuss about that. Okay, so what is light? Light is an important form of energy which which help us to see the things and perform our day-to-day activities. Okay, so light is an important form of energy. This help us to see the things and perform our day-to-day activities. Okay, plants are preparing food for all the animals by using the light in a process is called as photosynthesis. Okay, plants preparing food for all animals by using the light only. That process is called as photosynthesis. We discussed about this photosynthesis in 6th class also. We cannot see the light directly, but we can see the effects produced by the light. We cannot see the effects produced by light. So we cannot see the light directly, but we can see the effects produced by the light. Light does not require any medium to travel. Okay, means it can travel through the vacuum also. So light does not require any medium to travel, means it travel through the vacuum also. What is the meaning of medium? We discussed in last chapter. Okay, now we will discuss what is the sources of light. An object which can emit light is called as source of light. So source of light is nothing but an object which can emit the light is called as source of light. The sun, stars are the examples of natural source of light. Sun and stars are the examples of natural source of light. Burning candle, burning lamps, glowing current bulbs. Okay, burning candle, burning lamps, glowing current bulbs are the examples of artificial light sources. Both natural and artificial sources of light are called as self-luminous bodies. Okay, both natural and artificial sources of light are called as self-luminous bodies. Speed of light in air or vacuum is 3 into 10 to the power of 8 meter per second. It means light travel a distance of 3 lakh kilometers in 1 second. Speed of light in air or vacuum is 3 into 10 to the power of 8 meter per second. It means light travel at a distance of 3 lakh kilometers in 1 second. No object can travel with more than this velocity. No object can travel with more than this velocity. The light from the sun takes around 8 minutes to reach the earth. So the light from the sun, it will take 8 minutes to reach the earth. The distance of a earth from the sun is around 15 crore kilometers. Okay, the distance between the sun and the earth is 15 crore kilometers. To reach the light from the sun to earth, it will take nearly 8 minutes. Okay, now we will discuss about optical medium. What is the meaning of optical medium? The material through which the light passes is called as optical medium. So through which material the light is passed, it is called as optical medium. Example: air, water, glass, oil, etc. These are the example for optical medium. Depending on the passing of light through the substances, all the substances can be classified into 3 groups. They are transparent medium, translucent medium, opaque medium. Okay, depending on passing of light through the substances, all the substances are classified into 3 groups. They are transparent medium, translucent medium, opaque medium. Transparent medium. So depending on the passing of light through the substance, all the substances can be classified into 3 groups. They are transparent medium, translucent medium, and opaque medium. So what is the meaning of transparent medium? The substance through which most of the light pass, it is called as transparent medium. Means the substances which allow the light to pass through them are called as transparent substances. Means the substance through which the most of the light pass, it is called as transparent medium. Example: clear glass, pure water, air, etc. Translucent medium. The substance through which the light passes partially is called as translucent medium. Example, paper soaked in oil, rough glass, dirty water. These are the example for translucent medium. Translucent medium is nothing but the substances through which the light passes partially is called as translucent medium. Example, paper soaked in oil, rough glass. Example for translucent medium. What is the meaning of opaque medium? The substance through which does not pass light is called as opaque medium. Example, wood, stone. The material which does not allow the light to pass through them are called as opaque substances. Example, wood, stone, etc. We will discuss about light ray. What is the meaning of light ray? The line along which the light energy is propagating is called as light ray. Light ray is nothing but the line which the light energy is propagating. It is called as light ray. What is the meaning of light beam? A bunch of light rays or collection of light rays is called as light beam or beam of light. This beam of light can be classified into three groups. They are parallel beam of light, convergent beam of light, and divergent beam of light. So what is the meaning of parallel beam of light? If the light rays are parallel to each other in a light beam, then it is called as parallel beam of light. If the light rays are parallel to each other in a light beam, then it is called as parallel beam of light. And what is the meaning of convergent beam of light? If the light rays are coming towards a point, then the beam of that beam of light rays is called as convergent beam of light. If the light rays are coming towards a point, then that beam of light rays is called as convergent beam of light. In this figure, we can observe that the light rays appears to be coming towards a point. This type of light rays are called as convergent beam of light. What is the meaning of divergent beam of light? If the light rays in a beam of light are spreading out from a point, it is called as divergent beam of light. So, in this figure, we can observe all the rays are appears to be spreading out from one point. This type of beam of light is called as divergent beam of light. So now we will discuss about the reflection of light by plane surfaces. In class 6th, we have learned about the shadows and we carried out many experiments with the light rays, and also we discussed the propagation of light. We discussed the rectilinear propagation of light, and light travels in a straight line. In class 7th, we learned the laws of reflection also. Okay. In 6th class, we learned about the shadows and we carried out many experiments with the light rays, and we discussed about the rectilinear propagation of light, and light travels in straight line. In 7th class, we learned the laws of reflection also. Let us recall some of them. A source of light, an object, an opaque object, a screen is needed to form a shadow, and light travels in a straight line. When light gets reflected from a surface, the angle of reflection is equal to angle of incidence. The incident ray, the normal at the point of incidence, and the reflected ray are lie in the same plane. The incident ray, the normal at the point of incidence, and the reflected ray are lie in the same plane. And you must have observed that shadows and images in your daily life. So we can observe the shadows and images in our daily life. Some questions might have come to your mind while observing these shadows or images. Why does our image appear thin or bulged out in some mirrors? Why is there a right and left inversion when we look into the mirror? Can we focus the sunlight at a point using the mirror instead of a magnifying glass? Why is the angle of reflection is equal to angle of incidence when the light rays get reflected from a surface? Are the angle of reflection and the angle of incidence also equal for reflection by curved surfaces? In this lesson, we are going to learn about the reflection of light in detail so that we can answer the above questions. Okay, in this lesson, we are going to learn about the reflection of light in detail. So by that we can answer to above question. Let's start with some activities based on your previous knowledge. Of image by pinhole camera. Recall how an image forms in a pinhole camera that you have learned in class 6. Already we discussed about the pinhole camera. Okay, once you recall how the images forms in a pinhole camera, draw a ray diagram of the formation of image in a pinhole camera. So here what would happen if we increase the size of the hole of the pinhole camera and observe the flame of the candle with the pinhole camera making a big hole. Try to draw the ray diagram for the formation of an image in pinhole camera with big hole. Look at the figure 1. By observing the figure, we can understood that the light rays coming from the top of the candle flame fall on the different points on the screen. Similarly, the rays coming from the bottom of the candle flame also fall on the different points on the screen. Thus, we get a blurred image on the screen due to big hole of the camera as shown in the figure. So, do you know how to prepare a pinhole camera? To prepare the pinhole camera, we have to take the two PVC pipes. Okay, so one big PVC pipe and one small PVC pipe. Okay, here take a small PVC pipe and cover it with a white sheet like that. Okay, apply some oil on that. Next to take a big PVC pipe and cover it with a black sheet and fix a rubber band to that and make small hole inside the small pipe in the big pipe and try to see the image and make a hole on the big PVC pipe in middle. Okay, on black chart. So or try to see the objects like trees or big buildings. Then we will get the image of the objects like big trees or candle on the inside the PVC pipe on white paper. Okay, so like that. What happen if we increase the size of the hole of the pinhole camera? So increase the size of the hole of the pinhole camera and observe the flame of the candle with the help of a camera by making a big hole and try to draw the ray diagram for the formation of image of a pinhole camera. So here by observing the figure we can understand light rays coming from the top of the candle flame fall at different points on the screen. Similarly, the light rays coming from the bottom of the candle flame also falls on the different points on the screen. Then we will get a blurred image on the screen due to big hole on the camera. Now think about the reflection of light and solve the task given below. A smart crow is on a tree at a point A as shown in the figure 2. Some grains are on the ground MN. If the crow wants to take the grain and reach the point B on the other tree as early as possible in least time, from where should the crow pick up the grains? Okay, a smart crow is on a tree at a point A as shown in the figure 2. Some grains are on the ground MN. If the crow wants to take the grain and reach to the point B on the other tree as early as possible in least time, from where should the crow pick up the grain? With the mathematical knowledge you have about the angles and triangles, can you guess the path that the crow select? If you cannot, read the following. The crow can pick the grain from any point on the ground, but the condition is select a point on the ground to reach the point B from point A in least possible time. Okay, so the crow pick up the grains from any point on the ground, but the condition is the crow select the path to reach the point B from A. It should select the path which is taking least time to travel. Okay, so let us find the shortest path. So observe some of the paths in figure 3. So here how many paths are there? A, C, B, A, D, B, A, E, B, A, F, B. So which among the paths ACB, ADB, AEB and AFB is the shortest path? So in these three, which is the shortest path? To compare the lengths of these paths, we make duplicates of them in such a way that all the duplicate paths meet at a point G as shown in the figure. So in this figure, CB equal to CG. So the length of the path ACB equal to AC plus CB, that equal to AC plus CG equal to ACG. Okay. So in this figure, CB equal to CG. So the length of the path ACB equal to AC plus CB equal to AC plus CG, that equal to ACG. The length of the path ACG is equal to the length of the path ACB. Similarly, the length of the path ADB equal to the length of the path ADG. Next, the length of the path AEB equal to length of the path AEG. The length of the path AFB equal to the length of the path AFG. If we observe the figure 4 carefully, you will notice that among the path ACG, ADG, AEG and AFG, the shortest path is AEG, because it is the straight line distance between the points A and G. Okay, so if you observe the figure carefully, we will notice that among this path ACG, ADG, AEG and AFG, the shortest path is AEG, because it is the straight line distance between the points A and G, and you can measure and check this using a scale, as AEG is equals to AEB. The path AEB is the shortest path to reach the point B from point A. Okay, so it would take the least time. So the smart crow will pick the grain from point E. Okay, so observe the path AEB once again in figure 5. So in figure 5, once you observe the path AEB. Okay, so if we draw a normal EE dash at a point E, okay, at the point E we should draw one normal EE dash. Okay, then we can easily find that the angle AEE dash is equal to angle E dash EB. Okay, so if we draw a normal EE dash at a point E, we can easily find the angle AEE dash and E dash E angle. Okay, we can find the angle AEE dash is equals to the angle E dash EB. Like the crow in the above situation, light also select the path which takes least time to travel. So like crow in the above situation, light also select the path which takes least time to travel. The principle was first given by Pierre de Fermat. Okay, so this principle was first given by Fermat, a French lawyer and an amateur mathematician. Okay, so like crows, light also select the path which is take least time to travel. This principle was first given by Fermat. So this is also called as Fermat principle. So it is also applicable to reflection of light. So when light reflected from a surface, it will reflect the path which takes least time. Okay, that's why the angle of incidence is equals to angle of reflection. So here it is also applicable for the laws of it is also applicable to the reflection of light. When light gets reflected from a surface, it selects the path which takes a least time to travel. So that's why the angle of incidence is equal to angle of reflection. And which line segment can be considered as a mirror in the above activity? In that, which is acting like a mirror in this above activity? MN, this is acting like a mirror. We know that the plane mirror is a surface. How can we denote it? The ray diagrams. Okay, so we know that the plane mirror is a surface. So how can we denote it in ray diagrams? So let us know about the plane mirror before going to discuss the reflection of light on plane surfaces and also know about the ray diagrams. So here one smart crow is on the TA and some grains are there on the MN, and it pick up the grains and to reach the point B, which path is selected. So many paths are there, but the crow select the path which is taking least time to travel. In this, which is the path taking least time to travel? AEB is the path which is taking least time to travel. Like the crow, light also select the path which is taking least time to travel. This principle is first given by Fermat. It is called as Fermat principle. So it is also applicable for reflection of light. That's why when the light reflected from a surface, the angle of incidence is equal to angle of reflection. Why? Because the light select the path which is taking least time to travel.